tried pulling on my leash and there was nothing, and it was pitch black. And I just realized that I had to relax and wait. You know, my body will bring me to the surface. I'm buoyant, so just kind of calmed down and then made my way to shore, and it scared the daylights out of me. So ever since that moment, I've realized that I need to check the reports and I need to be on top of conditions and what's going on, and also not surf alone is one really important rule. I rely on surfing for my mental escape day to day, and waves and wave observations are really important so I can know where to go, how to be safe about it, and maybe where to go to get the most efficient surf. So yeah, knowing the conditions has become part of my regular everyday routine. The Coastal Data Information Program, or CDIP, maintains over 60 buoys around the entire U.S. that capture information on waves and temperature, and these buoys also contribute to beach studies. In addition to buoys around the U.S., we have buoys in the Marshall Islands, Guam, and Puerto Rico. I was hired as the Public Relations Coordinator for CDIP. And basically, I make sure that the public is well informed on how to use the data and that government understands how important it is to our users. We have a range of users, from the military to surfers to engineers and planners and so many more. So in addition to the work I do with the wave buoys, I use the wave buoys to look at local conditions. The buoys are providing real-time measurements, updating every 30 minutes. They're also used for wave models. Breaking down the buoy from the top to the bottom, first we have the wave buoy top hats, and these are the ways that we communicate with the buoy. On the top hat we have solar panels. We have a high-frequency radio antenna so we can communicate on land, and we have a GPS component so we can track the location of the buoy, and we also have a way for it to go to the Iridium satellite network. Diving a little bit deeper into the buoy, we have 3 groups of batteries together that last about 18 months. Below the batteries, we have the error correction box, which is calculating the movement of the accelerometer. And the accelerometer is basically measuring all movement in every direction. And then under the accelerometer, we have the temperature gauge. Then moving further down into the ocean, we have 10 feet of chain and then a bungee. It allows the buoy to move freely through the water, and it allows us to get the most accurate measurement possible. Then after the bungee, we have polypropylene rope that is set up to be neutrally buoyant in the water column. Below that, we have the anchor on the bottom and an acoustic release that allows us to retrieve the mooring line, and the anchor is made of recycled chain. So one of the greatest strengths of CDIP is that as waves come into the near shore, we can provide a lot of detail. So waves change as they come from deeper waters into the near shore, and this is because of a lot of complexities like deep water canyons or island shadowing or headlands, and all of these complexities can change the wave field. So we do a lot of work here at CDIP to make sure that our buoys are working properly. And we have people around the clock looking at all of these wave measurements to make sure that they're accurate and they're really good for our users. From time to time, I'll go out and I help clean the growth off of the buoys. We also have a lot of people here that are looking at other disturbances, whether someone's tying up to it or a buoy's maybe been hit or cut. We have a really great reputation here at CDIP for providing this reliable network of wave buoys. Forecasting waves has its own suite of complex variables and considerations. There are a lot of really great books to help people figure out what's going on out there. One of the books that I really like is Surfline's California Surf Guide Secrets to Finding the Best Waves by Sean Collins. The best way I can describe surf forecasting would be through tracking a storm in its entirety.
So what we're looking at is satellite imagery collected by NASA, by the GOES project. We're looking at Hurricane Marie on August 27th, I believe. And they start out often as depressions, and they're not named. So they start out every year, they start out alphabetically. They have the names figured out before the season starts. This was well into the hurricane season, so this is M for Marie. Marie reached Category 5. And it was the 7th strongest hurricane in the Eastern Pacific area. You know, they start off the coast of Mexico or Central America, and they veer up and follow the coast. And many of them will make landfall along in between Cabo and Manzanillo. Some spin off west towards Hawaii, the Hawaiian Islands. Whereas, you know, it's very unique for one to come this close where we'll actually see weather systems from it, such as like rain, or definitely we'll see the waves. The waves always come, you know, but we'll see like a tropical system sometimes come up here.
So when you see an observation from our buoys that's reading, for example, 4 feet, 16 seconds, 199 degrees, this can tell you that the significant wave height is 4 feet and the period is 16 seconds, which would be a long period because it's over 10 seconds. And 199 refers to the angle, and you can think of this like a compass. So on a compass, true north would be 0 and 360, and south would be 180. So 199 degrees is close to 180. So we know that this is a south swell. It's hitting the buoy at 4 feet, and the period is 16 seconds.
The strength of the storm determines the frequency of the wave field that comes at us. So, and that's what's normally called as period. Clearly, the stronger the winds and the longer they blow, we get a longer, stronger period, which oftentimes causes more damage along the coast and for bigger waves. And 3 meter or 9 foot wave that's measured in the outer waters can actually culminate into a 20 or 30 foot wave if it's a very strong, long period.
Period is often described as wavelength. And period refers to the time it takes to get from one peak of a wave to the next. For example, anything under 10 seconds we consider short period, and anything over 10 seconds we consider long period swell. And as a surfer, I'm looking for a long period swell. So some factors are depth or bathymetry. Like Blacks, for example, has a deep water canyon that funnels tons and tons of energy right to Blacks.
Those waves hit the buoy, they're maybe 9 feet, 3 meters or so, approximately. and then that's the outer water. And when it hits shallow water, they shoal and could see anywhere from 2 to 3 times that. So they were seeing waves
Wow.
20 to 30 feet hitting the
Jeez.
actual coast. So south-facing beaches were totally exposed and slammed.
But wait, there's more. It really depends on where you're located to figuring out what the swell is doing. On a south swell, Scripps hardly receives any of that energy because it's blocked by the cove. And then other areas down in San Diego may not see
Right.
that much energy.
So stuff
right?
that's north-facing would be totally unfazed by this,
Yeah.
you know? And so that's the one thing that's very unique about our coastline in Southern California is the wave field along the coast. That is how the wave heights vary from one location to the next because of a number of factors, because of the our coastline bending. But I mean, the amount of variability is pronounced, especially in wintertime. And you know, we don't get to see we see it mostly in the wintertime because of Point Conception up at the north, and it shadows a lot of the waves in Southern California,
Right.
which was reversed for Marie, where we got the full brunt of the storm hitting us, you know, and maybe some of the other places were shadowed. It was like the opposite effect.
Yeah. I actually like to keep a journal of different wave conditions, so I can start looking at the pattern of what's going on at my local home breaks and see how different swell directions and periods are affecting the spots that I like to surf. And you can kind of compare your own observation to the buoy, the websites, and then kind of bring it all home. Over time, you'll start to notice these patterns of, okay, Surfline was saying this, and this was the reading at the buoy, and this is how it's translating to me, and kind of what I noticed too while I was out there. That's probably the most important observation. So I've come a long way from paddling out in conditions that I didn't know were happening and getting in way too over my head. Now, I mean, I've kept a journal and I've studied CDIP wave measurements, and now I speak on behalf of CDIP and the Wave Buoy program. By keeping a journal, I've really learned different swell patterns, direction, how period affects the waves, and wave height. And I've kind of been able to bring it all home and know my local conditions really well.